Now I'm going to show you how to do a linear regression. So a linear regression is like finding the line of best fit that would go through your scatter graph. So if you've done scatter graphs, it's trying to find the equation of the line of best fit, like the y equals mx plus c, that would go through that. So you only do a linear regression if you have some kind of correlation, like if you've got a moderate, a strong one, even a weak one's not too bad, but if you've got no correlation, then definitely don't do a linear regression or actually get docked marks for doing that. Okay, so to start with, I'm going to show you the short way first, and then I'm going to show you the long way. So to start with, if you've got your scatter graphs already done, just go to your scatter graphs. If not, you would copy and paste your data and you would make a scatter graph. So I'm going to do it for scatter graph 1 the short way. So here's my scatter graph 1 all ready to go. So I've pasted that into my IA without the line of best fit on it. And now I'm going to click on it, or maybe double click even. Get rid of that thing out there. So double click on it, and when you double click on it, you see add chart element will pop up here. So I sort of I didn't click on the graph anywhere, I clicked off to the side. And then go to add chart element, and see down the bottom there is trend line. And we want to do a linear one, but we want some more trend line options. We want linear, and we want to display equation on chart. So we had to go to trend line options to do that. We select linear and display equation on chart, and then we're pretty good to go then. And you can see, actually, if I close that now, here it is. Here's my equation of the line of best fit. Notice it's drawn the line of best fit for us, and also it's also included the equation. And I'll just, so the equation's not sitting somewhere weird, I'll pop the equation maybe somewhere, I don't know, somewhere a bit less annoying. I know even where it is currently okay. So I might pop it there. So there's the equation of the line of best fit. You can see, according to this one, my gradient is 0.0003. That's the value of my gradient, like the rise over the run. And my y-intercept is 0.0593. So the y-intercept means at what point does this line of best fit cut the y-axis? And it's kind of hard to see, but it's right down at 0.0593. Okay, so that's how you find the linear regression, the equation of the least squares regression line, the short way. So now I'm about to show you the long way, which is kind of a bit more difficult. I'll just show you a little overview. This is the general equation that you use to find the line of best fit using the long method. We need to set up a table where we've got 4 columns. We've got our x data, we've got our y data, so that's just your x and y data that you made your scatter graphs with. We need another column for x multiplied by y, and we need another column for x squared. And we're going to find out the sums of these values. So it's going to require us to find the sums of all of these 4. So let's start to do that on Excel. So you want to copy and paste over your data, maybe put it in a new section. So I'll go to my raw data. There's my X, GDP per capita. Here's my Y, carbon dioxide per capita. So I'm going to Control C, and I'm going to put that into a new sheet over here. Here's my X and Y data. And I might rename this sheet. Might be a good idea to rename it. I'm going to rename it linreg 1, just so I realize that's my linear regression. So here's my X data here. Here's my Y data here. Looking back on here, the other columns we needed are X, Y, and X squared. So let's do that. So if you want, just go X, Y. That's easy enough to type in. And X squared, maybe just write it like this for now. And you can always make it look nice when you've got it in Word. So I might just centralize them. And these are easy to calculate using your formulas. Like XY just means your X number multiplied by your Y number. So that's easy enough to do. So go equals, click on your X, and multiply sign is that shift 8, makes the star. Click on your Y, so see I've got X times Y, and press enter. And we can scroll down like before. Remember, you click on the cell, you've got the fat cross, and then go to the bottom right, you've got the skinny cross. So click and drag down to the bottom. That matches up. So that's been all worked out for us. And now what we've got to do is X squared. So basically it's this value times itself. So you're going to go equals, click on the X value, and you can either go multiplied by itself, or you can go squared, like to the power of 2. That's a little shortcut. There we go. click on the cell, so you've got the fat cross, go to the bottom right corner, and this cross becomes skinny, and scroll down. And we will need, so notice things like 9e.08, it just means like it's a big number. So you can stretch across if your numbers are coming up a bit weird. You might want to stretch your numbers across, your columns across, I mean, so that it kind of fits a bit better. So definitely save as you go, because that's important. Like, see how I just saved my work. Now what we need is the sums down the bottom. So to do our sums, you probably, if you've done a Pearson's, possibly you know how to do your sums already. So we go equals SUM, double click on sum, and to be honest I can go from the bottom up, but I'm in the habit of going up to the top first and selecting downwards instead. So down to 51 is where I've got, close my brackets, enter. So there's my first sum. I'm going to make it bold and red just so it stands out a bit. And to find the sums of all the other columns, it's easy. You can just make the arrow go, like, you know, hang around the bottom right corner, click and scroll across. And there's my other sums. So these are values that are really important, and I'm going to need to paste them into my table. So in Word, I would have a table with my X value, whatever it is. I would paste it in, like GDP per capita, blah, blah. And I would paste in CO2 per capita. And then if you want, like, put X, Y, and X squared in there. And I'll need to enter a column beneath there. So I'm going to insert, so not a column, a row. Insert row below. And I'm going to try to paste these numbers in there now. So let's see. Sometimes if you, let's see what happens when I try to paste it into this right now. Is it going to work? Yeah, it did. Okay, cool. So now maybe I would save what you've just done there as well. Save, and I should also save my work here. That's also important. Keep saving as you go, because you don't have to do this all again. So that's the equation that we start off to find the linear regression with. And I've got it also down here. So now we're going to have to start to work things out. We're going to have to work out what this S of xy is and S of x squared. So S of xy is the sum of my xy. So you can see it's my sum of my xy here, minus my sum of x, which is that, multiplied by my sum of y, which is that, divided by n, which is how many countries I've got. And if you look at my table, my countries go from 2 down to 51. So just be sure that you've got the right amount. See count, I've got 50 countries. So I happen to have 50 countries, but you're going to have a different amount of countries to what I've got possibly. So let's start to work these things out. So you'll need to type these things up. SXY equals sum of xy plus all of this stuff using your equation editor. And I would suggest that you kind of pause this video and do that now, because it takes ages. So now we've got to type in the sum of xy, which is just this number here. So Control C, let's paste that in over here. Sum of xy, and then see it's minus. So minus. Now we've got to make this fraction. So to make a fraction, go insert. Sorry, I've got that there in the way. So insert equation. And we want to make a fraction. So I'll select the first fraction. And what needs to go in here is the sum of x multiplied by the sum of y. Here's my sum of x. So go Control C. It's hard to get in there. Place that in there. Multiplied by, so to do a nice multiply sign, let's do it with insert equation. See, there's a multiply sign there. Multiplied by the sum of y. You could manually type these numbers too, that also works. Control V, the sum of y. Maybe I'll zoom in a bit so you can see it a bit better. It's a little bit hard to see what's going on, so I'll put a space there. So I've got my sum of x times my sum of y, and the n is how many countries I've got. So you'll have a different amount of countries to me. So you probably aren't typing in 50, you're typing in maybe 48 or 36 or however many results you've got in your table. So just make sure you put in the right number. Some people put in the wrong number. And that has kind of been partly worked out. And then eventually we're going to have to calculate this as well. And a quick way you might want to calculate this is in your Excel table. So notice you basically take this XY value here and you minus these two times together and divide it by how many countries you've got. So I can do that in my Excel spreadsheet. So I might want to scroll down a bit somewhere. So notice what we're finding, by the way. We're finding S of XY. So you might just want to write that over here somewhere. SXY, just so we remember what we were doing. So it's going to equal, remember looking back if you forget, it's that number there, sum of XY minus these two numbers multiplied together, divide by how many countries or surveys you've got. So it's going to be equals that number minus, if you're not sure you can use brackets, but order of operations is going to work here fine. So, but if you're a bit worried, put brackets around there. So these two numbers multiplied by each other. Remember to do multiply, you do star, close my bracket, and then divide by, I've got 50 countries, but remember you might not use 50. You might have a different amount. So that's my number. That's what my SXY ends up equaling. So I might go Control C, and let's see if it's going to paste. Control V, yes it did. Okay, sometimes it does, sometimes it doesn't. In this case it did, which is great. So we've just found the S of XY. Now we've got to calculate this business, which just became smaller. So S of X squared is basically the sum of your X squared, which is this number here, minus the sum of your X, but all that number squared, divided by N. So let's set this one up. So the sum of X squared is your number here. So sum of X squared, there it is. And notice it's minus now, so do minus. And we've got a fraction again. So let's go insert, equation, fraction. There we go. And it's the sum of X all squared. So you're going to need to make an exponent, because everything's going to be squared. And your sum of X is going to be inside those brackets. So your sum of X is this number here. Control C. Let's go back to here. Control V. Don't forget to close your brackets. So see, that makes sense. That's the sum of your X all squared over N. And remember, my N is 50. Your N is probably a different value. And definitely save what you've done so far. It's a good idea. And now we can calculate what all of this equals in Excel, kind of similarly how we did here. So you can see it's going to be equal to this big number here, minus this number squared, and then divide that by 50. So let's set that up in Excel. So again, like, what is it called again? It's the SX squared. So let's just do a rough typing of what that is. I'll just write SX like this, just so when you look back in your Excel sheet, you can remember what this number was about. So it's equals, looking back on here if you forget, that number minus this number squared, divide by how many surveys or countries you've got. So equals this number minus, and I might use brackets just to be on the safe side, your X squared, you probably don't need brackets really though, close brackets, divide by however many surveys or countries you've got. I've got 50. And press enter. So that's a pretty big number. You go Control C, go back over to your Word document and paste that thing in there. Again, definitely save your work because it'd be horrible to have to do this again. And now we've got to sub all of this into this here equation down here. Y minus the mean of Y, and so on. So we've also, if you don't have your mean of X and your mean of Y, you want to calculate those in Excel now. So I'll just show you how to do that if you haven't already got that. So you need your mean X and you need your mean of Y. So mean of X, in Excel, they call it the average. So go AVE, double click on the second one, which is average, and select all the numbers you want the average for. So we want it for the X. So don't select the heading, just select the numbers. Don't select the totals at the bottom. That's why it's good to highlight them and make it clear that that's the totals. So that's your average X value, which makes sense looking at those numbers. Now we've got to get the average Y. So go equals AVE, oops, AVE, average. Now let's select our numbers for Y, don't select the titles. So as you can see, these are much smaller numbers. Only don't go to the totals. There it is. So that makes sense. An average y value could be something like 5 point something. So here you've got the mean of x and the mean of y. So why did we do that for again? That's because you need that here. So we get, so you'll need to type this into yours, or you can paste in the equation, I guess, up to you. So y minus the mean of y. So let's paste in our mean of y. Here's our mean of y, Control C. Paste in your mean of y, Control V. Then it's equals. Let's make a nice little fraction. So because we're going to do this now. Insert equation, fraction. What needs to go in here is your s of xy. And see, s of xy is that number you found over here. So Control C, Control V, s of xy. What goes on the bottom is your s of x squared, which you can see is this number here. S of x squared, Control C, Control V to paste that in. Now I've got some big brackets going on here. So let's put some brackets, and it's x minus the mean of x. And the mean of x you've got in here as well. The mean of x. Oops. That kind of thing happens. Just do that. Control C. Mean of x. Let's close that bracket. Okay, so that's taking up a lot of space on my page, so bracket didn't appear. Let's stretch it out a bit. That's better. Okay, so it's all on one line. And this is pretty close to being done. We need to just work out what that divided by that number is. And if you're not sure, you can always do that on Excel as well. So you might want to kind of just copy and paste what you've done so far and just pop it on the next line. So maybe I'll put this down here, and then the next line I'll repeat it. And now I'm going to work out what this actual number is. So it's this 44 number and this 137 number. So you can do that in Excel. So let's go equals my top number here, divide by / that number, enter. So that's a pretty big number. So Control C, let's copy and paste that in. So I've just worked out what this whole fraction was. So it was Control V. Something just went wrong. I deleted my bracket there, my mistake. So I should instead still have my x minus that thing, but I've now turned this fraction. Oops, I just did it in the wrong order. I should have done it. So let's Control C. I just should have done it on the row below. There you go. So that's in the right order now. See, I've got the fraction version here, and now I've worked out what that divided by that actually equals that number. And now I need to do some expanding. I need to do this times this, and this times this. So we're so close to being finished. So we've still got, I would suggest, Control C again, and Control V. So we've got to do, obviously, this number times x is just that number times x. So that's easily done, just delete the bracket. But this number times that number, you need to work out. So maybe you want to kind of do that in your Excel spreadsheet as well. It's this number multiplied, because we're expanding the brackets. That times that equals that x, that times that equals a number. So let's work out what that was. So we can do that here if you want, equals this number multiplied by, and it was this number here, the mean of x, multiplied by your mean of x. So here's that number, Control C. So instead of having that there, I should have that number, because this number times that equals that number. Makes sense, because a really small number times a big number becomes maybe just a regular number. And we're really close to being finished, super fast, super close to being finished. Control C again, because it's very repetitive. You just got to do tiny new things on each line. See, I've got y minus something equals something x minus something. We've just got to add the 5.07 thing to the other side. So maybe you want to, let's see, we're going to take it away from here. Control C, maybe delete that off. And then because it was minus on this side, you're going to add it over here. So maybe we want to show that step. Plus Control V. Again, so close to being finished. So we know we've got this bit down here. We've just got to work out what is this negative 5.01 something plus 5.07 something. So again, you can probably do that in Excel. See, here's the two. So negative 5.01. So you might want to go equals negative brackets of this, close brackets. So it was in the negative of that plus this number. So the negative of that plus your 5.07 number, which is that number over here, the mean of y. And we've got this lovely number now. So Control C. Here we go. And that is a positive number, so we'll just go plus. And that is our equation of the line of best fit. And what you can do is you can check, is this the right answer, like y equals mx plus c, by looking back at your scatter graph. So we've got like roughly 0.0003 x plus 0.0593 blah blah. So let's check that on our scatter graph that we did. So I'll go to my scatter 1, and here was the line of best fit I just found at the beginning of the video. Yep, see, it is positive 0.0003 plus 0.0593. 0.0003 plus 0.0593. It's just that on this version it's a bit rounded, whereas here on my one it's less rounded. So you might then want to quote your final answer. It's up to you what you round it to, of course. If you were to round it to 3 sig figs, for example, you would do another line. And 3 sig figs, it would be 0.000, because the zeros aren't significant, 3 to 3, because the 7 rounds that 2 up to a 3. And this would be 0.00, because they're not significant, 593, if you were to round it to 3 sig figs. And that would be my final answer. So if you don't like these numbers being in red up here, you might just want to change them, I don't know, back to the regular colour. And that's your equation of your line of best fit. So what it means is that the gradient, looking at your scatter graph, as you go up by 1 for each GDP per capita, the carbon dioxide emissions go up by 0.0003. That's what basically it means, and that the y-intercept is 0.0593. So you've just found the equation of the line of best fit. What is the whole point of it is you could always make predictions with this equation of line of best fit. Like, for example, if you wanted to predict, say, a country that maybe has a GDP per capita of 60,000, then you could just substitute into your equation. So if the GDP per capita was 60,000, you could potentially calculate an example of what its carbon dioxide emissions would roughly be according to our model. So we would just substitute in x equals 60,000 and calculate what the y is to get the carbon dioxide emissions. So that's one example of how you can actually use the line of best fit. So it's good to sort of talk about it afterwards a little bit, like not just find it and say nothing about it. Maybe use it to calculate some examples of predictions or something like that. And just remember to talk about the fact that you've got the gradient here and the y-intercept here and that kind of thing.